A-level experiment. This one is trying to verify that F equals ma force equals mass times acceleration. So we've got a linear air track. This is going to remove the friction from this little air track vehicle. And what's going to make the air track vehicle is the bit of string is connected to a pulley. If we go down to the other end, we've got a mass on the other end. Now the M that we're looking for here isn't just the mass of this vehicle, it's the mass of the overall system. So to make the vehicle accelerate, obviously we need to add more masses on this end, but we can't just add them from a separate stack. What we have to do is we have to take the masses from here, take it from here, and then transfer the mass onto the hanger. Now when we do that, the overall mass of the system remains constant, but the force that we're applying is increased. So we should find out, hopefully, that as we increase the force, we increase the acceleration. If we plot the force against the acceleration, the gradient should be the mass straight through it. To do it though, we're not using a computer like a system force. What we've got is normal digital timing. So we've got a digital timing circuit. So we've got inputs from this light gate here, inputs from the second light gate there. This one measures the time effectively for the card to pass through it. Now we know the length of the card is 10 centimeters, so that can work out the speed here, the velocity at this point. Same thing over there, but because it's speeding up, the velocity at this gate is going to be higher than the velocity at this gate. And the timer also knows the time to go between the two gates. So we get our final velocity, we've got our initial velocity, we've got the time between the two, that gives us the acceleration. Now it doesn't really matter if the card gets skewed as well. All that's going to do is make the apparent length of the card shorter, so the time would be shorter, so the velocities would be up. But it would be the same effect on this gate as it is on this gate. That's pretty much it. So the air track again is just remove the action of friction. We've then effectively got no frictional force acting. The only force acting we've got is the accelerating force of the masses on the end, and the overall mass of the system must stay constant. We take the masses off here, add them onto there. So we'll just power this up, and we'll have a look at how it works in one go. So you want to hold the vehicle, sir, and then okay, so air track's going to go on. Okay, it's all good. So what we'll do is we'll do a few runs of this. We'll give the readings, the various times or the velocities that we've got. We'll put them on an Excel sheet. You can use that data, plot the appropriate graph of force against acceleration, and you should get the gradient equal to the overall mass of the system. We'll also put the mass of the system online, see how close your graph gives you to your real answer, and then you can look at the possible percentage error terms in that as well.